Good morning students and welcome to our YouTube channel Gnan Manjari Modern School. Okay students, so in the previous video Harshal ma'am started the new chapter, that was chapter number 9, force and laws of motions. Okay students, what is motion? You have just seen in the previous chapters and also taught by the Harshal ma'am. Okay students, now we will see that now we will see further in the force and laws of motion in the chapter number 9, that we will go to the further. Okay students, in that the very first Harshal ma'am taught about the force. In the previous video ma'am has taught about the force, that what is force and how it is act. Okay students, and then we have seen the balanced and unbalanced. Here we have seen the balanced and unbalanced forces. So that also the balanced and unbalanced force. So that was also taught by the Harshal ma'am in the previous video. Harshal ma'am has taught in the previous video, just started the new chapter, that was chapter number 9, force and laws of motion. In that ma'am has taught about the force, about the introductions and balanced and unbalanced forces. Now we will go further with the laws of motion, that what is the laws of motion and how many laws are there in the motion. The first law of motion, what the first law of motion, first law of motion. So what is the first law of motion? Let me write that in the board. What is the first law of motion? I am writing in the board. See here, an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. So students, this is the first law of motion. Let us read that. An object remains in a state of rest, means if I tell this is an object, here is an object. If an object remains in a state of rest, first we are talking about the rest or of uniform motion. We will take that in the another example. If an object remains in a state of rest, means the object, this is an object, remains a state of rest means remains here only, and unless completed to change that state by an applied force. Okay students, if I talk about this object is here only. Okay students, then if I tell that object go to here, it will go over here. Or if I just take an routine example of it, see here students, there is a duster in my hand, and if I tell the duster please rub the board, why this duster is not rubbing the board? Duster, I am saying again it, duster please rub the board. No, he is just not listening. It is just not listening. If I use my hand and applied an external force, an applied force or external force on it, then it will rub. Okay students, so what you have studied in that, if there is an object, if I say this is an object, then if it is in a rest state, okay students, and up till and unless it will not move from here up till the external or applied force is applied on it. Are you understanding students? I am just taking a basic example. Let me this say in Gujarati. તમને બધાને ખબર છે, તમે લગભગ ફર્સ્ટ લો ઓફ મોશન બધા યુઝ કરતા હશો. જ્યારે ફ્રેન્ડ્સ ગ્રુપ ભેગું થાય, બધા શાંતિથી બેઠા હોય, પણ ક્યાં સુધી બધા શાંતિથી બેઠા હોય? જ્યાં સુધી તમે કોકની હળી ન કરો. અને જો તમે હળી કરો એટલે તમારી હળી શરૂ થઈ જાય. ઓકે સ્ટુડન્ટ્સ, સો what we have learned from this first law of motion, that if we don't give an external force or applied force in any object, it will stay in the rest only. Okay students, it will stay rest only here. Now we will move further with this was state of rest. Now I think the object is moving in the uniform motion in a straight line. Okay students, now we will go on this. See here students, now there is an object. If I tell that students, this is an object and it is moving with uniform motion. Okay students, an object is moving with uniform motion. See here, an object in the uniform motion in a straight line. Now we are not taking state of rest, I have already taught you. And if an object is in the uniform motion, which uniform motion? You have studied about what is uniform motion and what is ununiform motion. Okay students, so there is an object. See here students, this is an object. It is going straight. Okay students, in the uniform motion, it will go and go and go. It will not stop or don't change the direction. If I want this object to turn right, I want this object to turn right. So I will tell that object, please after some distance take the right. It will take right. Just think you are driving a car. Okay students, you are going at the 60 km/h in the uniform speed. Okay students, you are going, there is a straight line, a straight highway, and you are going in the 60 km/h in the speed, and then after you take the hands off the steering. Okay students, I am not talking about the advanced car. I am just talking about the cars which are there in India. I am not talking about the advanced car. You are going with 60 km per hour in a uniform speed, uniform motion. Okay, students, and then after you want to take right. Okay, students, then you just take off the hands from the steering and just say the car that please take right from the next right from 1 kilometer. If I tell that, or please take the next right to the car, I will say that, then the car will take the right at uniform speed. It will take or not. It will not take. What you have to do, you have to apply force on it. You have to just slow the speed and just turn the steering to the right, so it will go the right and take the right. Okay, students, so this is the first law of motion. What? An object remains in a state of rest or of uniform motion in a straight line unless completed to change that state by an applied force. Means, in the Desi Bhasha, in Gujarati, we can say that જ્યાં સુધી આપણે કોઈની હળી ન કરીએ ત્યાં સુધી એ આમનામ જ રહે. Okay, students, so what I have given the example, if very first we will see it again. If I tell this duster, please rub the board, it will rub the board, it will not rub the board. Okay, students, but I have to take it in my hand and put it in the board. Okay, I have just put it in the board. Now I will tell the duster, please rub this line and the written object and that line. Why this duster is not rubbing the board? Can anybody tell me, students? Why? We have to apply an external or applied force on the duster so that the board can get rubbed. Okay, students, this was the state. Here we take another example. In standard 9th, I know many are of the footballers. I know many are of footballers. See here, if you thought there is a penalty shootout in the football match, and it's your captain said you that take the penalty. So here is an goal post. Here the goal key is standing. I don't know the drawing very much, and here is the ball, and here you are standing, and you just have to take the goal. Okay, students, let us imagine that my captain has told me to take the penalty. Okay, students, then what will happen? I put the board and there far is a goal post. Then what I have to do? I will tell the ball that ball go into the goal post. It will go, students. It will go or not go. It will not just move up till when we do not apply an external force. I will put here ball and tell that ball that go inside the goal post. It will not go. What I have to do? I have to just kick so that it will go to the goal post. By kicking, what I have applied, and I am applied an external force. From that force, the ball is moving. Okay, students, and go to the goal post. I don't hit the goal, but just it go and just this goal key catch the ball. Okay, students, I have my penalty shootout was failed. It was just a ball was taken by the goal key. So we lost the match. Okay, students. Okay, next example. Here it was the state of rest. This example was state of rest. Next we take here there is an example in your textbook. So, what is that example? My drawing is not very, you can understand that I don't draw. No, this angle is not proper, it is a right angle triangle. We don't want this. We will draw a right angle triangle only, but the slope will be more. Okay students, you just have here, it is just upper side, this is not proper, so I don't know the drawing. Okay students, you can say that from this. Okay, now I think it is proper. If I put a ball over here, small ball, not football, okay students, because it is not too much large, it is small, so we have just put a ball also small. So what will happen? If I put that ball over here, what will happen? If I say I have just hold the ball, okay students, and then I will say અહીંથી હલતો નહીં, હું તને મૂકી દઉં પછી પણ, તો બોલ ત્યાં ને ત્યાં રહેશે? Ball वहाँ के वहीं रहेगी? No, it will start moving the downward. Why? There is a slope, so it will move downward. Okay students, so what will happen? The ball will move. After some times, not after some seconds, it will be here. After some seconds, it will be here. After some seconds, it will be here. And here is an straight line, so this will go this, and after some time ball will be tired of walking, so it will come to the rest. Why? Due to the some of the external force, gravitational force, the ball will stop after some distance. Why? Because there are some of the external force applied on it, or gravitational force, so that after some times it will stop. You have all have experiment and all have cycle. After, if there is an slope, you just don't have to pedal the cycle and it will go. And how much the cycle will go? After the slope overs, some distance the cycle will go, and after some distance you have to put the pedals so that your cycle can go further. In this way it will just move move at some distance. And next, here what we will do next? Now if I take, so students, law of motion we are using only. The duster do not rub the board until and unless I just hold the duster and move and applied force on it. Okay students, this is the first law of motion. See here students, I just drew another slope over here. Here is a straight line. No, this is not straight line, it's okay, it will work. This is an slope, another slope. So as we put this ball, it will go, and after some distance I just put another slope of climbing. So what will do? It will go downward, then at some time it will go upside. It will not go up above here, but at some distance it will remain and come back over here, and then it will go back over here, then it will go back, then back, and after some time it will be steady at this. I think in which I have seen this, I am not reminding that name. So this ball will move here, then it will go up, then it will go up, and at some distance it will stop there and come back. Okay, students, so this was the first law of motion. I think you will understand it because I have taught you about in the simple language. Okay, students, now just we are reading the textual content. I am not missing the any points of the textbook. Let us see that. So I am reading the textual content of the this first law of motion. Okay, students. So here in the page number 116, first law of motion 9.2. By observing the motion of the object on an inclining plane, Galileo deduced that objects move with a constant speed. When no force acts on them, he observes that when a marble rolls down an inclined plane, its velocity increases. In next chapter, you will learn that the marble falls under the unbalanced force of gravity and it rolls down and attains a definite velocity. By the time it reaches to the bottom, its velocity decreases when it climbs as shown in the 9.5b. We are reading this one. In Galileo just put a marble. Okay, students, we have just put the ball, but now we will put the marble. Now you have just to imagine that it is not a ball, it is a marble. Okay, students. So if I put a marble, it will increase the velocity. Okay, students, the speed will be increased of the marble, and then after at this stage the velocity will not increase, and after some time it will, as it go up, the velocity will be decreased. Okay, students, or the speed will be decreased. Now next, as you seen in the figure 9.5b, this figure is drawn over here. You can see that in figure 9.5c shows a marble resting on an ideal frictionless plane inclining on both sides. Galileo argued that when a marble is released from left, it would roll down the slope and go up on the opposite direction to the same height from which it was released. If inclination of the planes on both sides are equal, then the marble will climb the same distance that is covered while rolling down. If the angle of inclination of the right side plane will gradually decrease, then the marble would travel further distance till it reached the original height. Okay, students, what Galileo tells? Okay, students, let us see that if there is no external force on it, or if there is some of the external force on it, what will happen? I put a marble. No, Galileo has put a marble. I haven't put. Okay, students, Galileo has put over a marble, and I think this both height is not same. Okay, students, as you know, my drawing is weak, so as you have, Galileo has put a marble, it will go downward, and it will climb a slope up to the height over here. This is the height. It will climb over here. I know that this is not a straight line. Just you have to imagine that it is a straight line. This height the ball has to be achieved. Okay, students. Here the ball has reached. Okay, students, I have reached. I have drew that ball. So as the marble is released from here, the speed will increase, and after some time it will decrease and decrease, and up till this height is achieved. Okay, students, this height is achieved, it will go there, and then after it will come back. Okay, students, so this has the Galileo explained. Next we will read further. Where were we? Release. Okay. gradually decrease. Then the marble would travel further distance till it reached the original height. It will reach up to the original height. Which height? From this which height we have released them, it will reach up to that height. Okay students, next, if the right side plane were ultimately made horizontal, that is the slope is reduced to 0, means I haven't built here the slope and it is a straight line. Further before I have drawn that, the marble would continue to travel forever trying to reach the same height that was released from the unbalanced force on the marble, in this case are 0. So, it will, if there is no slope, okay students, then it will, as we release the marble from here, it will go further and up till it will not stop up till the height, the same height is not achieved. Okay students, next, where were we? It thus suggests that an unbalanced force is required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. In practical situation, it is difficult to achieve zero unbalanced force. This is because of the presence of friction force acting opposite to the direction of motion. It will not occur in the real. Why? Because due to there is some of the we can't achieve the zero unbalanced force. Why we can't achieve? Due to the friction force which is acting opposite to this force, or we can't achieve to the zero unbalanced force. So that in practical we can't, the marble will not go up to the height, it will go up to the some height only, it will not go to the original height from which we have released. Okay students, next, thus in practice the marble stops after traveling some distance. The effect of the friction force may be minimized by using a smooth marble and a smooth plane and providing a lubricant on the top of the planes. There are some conditions from which we can travel that ball to the original, but not the original. There will be some variation in it. See here, next is Newton further studied Galileo's idea on the force and motion and presented three fundamental laws that governs the motion of the object. Galileo has just tell that, and further Newton has given the three fundamental laws. See here, these three laws are known as the Newton's law of motion. The first law of motion is started as, see here, the first law of motion. An object remains in a state of rest or of uniform motion in a straight line unless completed to the change that state by an applied force. This is the first law of motion. Okay students, in other words, I am reading from the textbook. In other words, all objects resist a change in their state of motion in qualitative way. The tendency of undisturbed objects to stay at rest or to keep moving with the same velocity is called inertia. What is inertia? It can be asked that. In qualitative way, the tendency of the undisturbed objects to stay at the rest or to keep moving with the same velocity is called inertia. You just have to underline this. What is inertia? It can be asked. See here, this is why the first law of motion is also known as the law of inertia. That is why this first law of motion is also known as law of inertia. But I will ask, what is inertia? I have just taught you before 30 seconds. What is inertia? Can you tell me without saying in the textbook? I have to see because I don't know. See here, I am reading it again in a qualitative way. The tendency of undisturbed object to stay at rest or to keep moving with the same velocity is called inertia. Okay, students, certain experience that we come across while driving in a motor car can be explained on the basis of law of inertia. We tend to remain at rest with respect to the seat until the driver applied a braking force to stop the motor car. With the applications of the brake, the car slows down, but our body tends to continue in the same state motion because of its inertia. A sudden application of brake may thus causes an injury to us. Okay, students, it injures us. Here in the next page, page number 117, there is an description about Galileo. You can read that. Okay, students. Next, what in the car, if there is a bump over ahead and the driver after some time knows that there is a bump and applies brake, then what will happen? We will just who are sitting in the car just come front. Why? Due to the inertia. We are having the same inertia, but as the motor car's driver brakes, we will just do this. Okay, students, impact or collision with the panels in front. Safety belts are worn to prevent such accidents. Means we all know seat belts are wear for the for the protection of our. Okay, students. Next, an opposite experience is encountered when we are standing in a bus and the bus begins to move sudden. If we are standing in the bus, okay, students, when the bus starts, just we go in the back side. Why? We are standing in the steady state, but as the bus have started, so we will go back, and then after some time we will come to the rest with the motion of the bus only. Okay, students, and if the driver brakes immediately, then what will happen? Just will come in the front. Okay, students. Next, thus this is because the sudden start of the bus brings motion to the bus as well as to our feet in contact with the floor of the bus, but the rest of our body opposes this motion because of its inertia. When a motor car makes a sharp turn at a high speed, we tend to get through to the one side. This can again be explained on the basis of law of inertia. We all know that just there is a high speed in our car. Okay, students, and driver immediately take turn, just turn. We will throw to the opposite direction. If the driver is taking turn this side, on the right side we will go to the left side. Okay, students, and if the driver takes the left side, we will go to the right side. Okay, students, why? Because the law of inertia. Next, we tend to continue our straight line motion when an unbalanced force is applied by the engine to change the direction of the motion of the motor car. We slip to one side of the seat due to the inertia of our body. The fact that a body will remain at rest unless act upon the unbalanced force can be illustrated through the following activities. See here, there is an carom board over here drawn in the figure activity 9.1. You can see the activity 9.1 in your textbook in the page number 117. Okay, students, and the activity 9.2. Okay, students, see in the activity what the carom. If we play carom, that what is called striker. Striker, if we don't hit the striker, it will not move. This is an activity you read first. You can read by yourself. Just I am reading that. Make a pile of a similar carom coins on a table as shown in the figure 9.6. Attempt a sharp horizontal hit at the bottom of the pile using another carom coin or a striker If it's strong enough, the bottom coin moves out quickly. When the lowest coin is removed, the inertia of the other comes, makes the fall vertically on the table. What will happen if there in the carom board, there over this are some of the coins or the that some coins over here, and if we hit with striker the lowest one, what will happen? The lowest will come out and another will fall. The lowest will come out with the law of inertia, and the another which are on the top of it will also come down with the law of inertia. Okay students, this is explained in that activity. Now activity number 9.2. Set a 5 rupee coin on a stiff card covering an empty glass tumbler standing on a table as shown in the figure 9.7. Giving the card a sharp horizontal flick with a finger. If we do not do it fast, then the card shoots away, allowing the coin fall vertical into the glass tumbler due to its inertia. The inertia of coin tries to maintain its state of the rest even when the card flows off. What is then this activity? This activity, just we can say we have to take an empty glass and we have to put one paper and above paper one coin. If we move the paper fast, then the paper will come out and the coin will go into the glass. Okay, so this is an activity. And the third activity 9.3, place a glass filled tumbler on a tray. Hold the tray and turn around as fast as you can. You will observe that water will not spill. Why? Observe that a glove is provided in a saucer for placing the tea cup. It prevents the cup from toppling over in case of sudden jerks. Okay students, these are some of the activities of it. Okay students, now it's time for your homework. Before that, I will just tell about the activity 9.3, that what was it. This, if we take one string or anything else and put the glass over it, okay students, and then if we move that, you have also seen some of the videos or in YouTube's or Instagrams or something else. Okay students, that they are moving the glass, but the glass is on the upside, then the water is not coming out. Why? Due to the inertia, law of inertia. The water in the glass will not come out of it. So that is the activity 9.3. Now it's time for your homework students. Please write down your homework. So your today's homework, you have to just read the first law of motion. Okay students, read the first law of motion. This is not only the first law of motion, you just have to by heart that statement, but you have to read just whole what I have explained today. Okay students, up till then stay safe, stay home. Okay, bye students.